That's really where the breakdown happens, is that across the system there's fragmentation and there's uneven implementation.
Hi Miranda, welcome to our conversation series and congratulations on your new report. The topic is concerning and highly relevant at the same time. And you have been studying the prevention of proliferation of biological weapons. And you have been in particular looking at the role of AI and the shared data systems, the so-called distributed ledger systems in that context. Maybe to start with, why are these technologies important to look at when we aim to control the spreading of biological weapons?
Sure, yeah, I think that that's a really key question to start with. The study of biology, we're looking at everything that is alive. The way that biological research is being conducted and managed across the globe is changing very rapidly. So the systems that we rely on to oversee that work and to demonstrate that we're compliant with safe work in biology have not really kept pace with these rapid changes. A lot of the biological weapons prohibition regime still relies on national reporting from member states. It relies on laboratory level oversight, hoping that everybody's doing the right thing. But we're finding that that is increasingly strained when there's a more complex, data-driven environment and ecosystem that is surrounding biological research. So the question isn't how we manage biological risk, it's how we demonstrate that the work that's being done in biological research is being done responsibly.
But do we have any international mechanisms in place, or where are the gaps?
We do have a number of mechanisms in place. But unfortunately, they operate quite differently across the entire system. At the core of that is the Biological Weapons Convention. That unfortunately relies a lot on accurate national reporting from states parties. And there's also other mechanisms that build up that system, including export controls, industry, scientific initiatives. There's several things that work together cohesively, or should, and that's really where the breakdown happens, is that across the system there's fragmentation and there's uneven implementation with those mechanisms. So it's not that the issue is a lack of mechanisms across the globe. It's really making those existing mechanisms work consistently in this more complex and data-driven environment.
But if I understood your study correctly, the states involved, they are in principle happy to report and they are happy to comply, but it seemed that the challenge is more in administrative capacity.
Yes.
Can you explain that?
Absolutely. Yeah, and that's a really important point because, of course, the kind of international norm against biological weapons is still very strong. And states are quite active in reporting and sharing, but it is a large task for those member states to undertake every year to report changes. And again, because of the distribution of biological research that's being done, it's very difficult to get an accurate picture of what activities are being conducted. So a lot of times the issue is not the willingness to report, it's the capacity to be able to actually do that. Reporting and oversight are always administratively heavy and can take a lot of time, and not all states have the capacity to do that.
I can really imagine that, but if we also see then how AI is in a way entering our life in many various ways and aiming to help, especially administrative burdens, isn't it highly extra sensitive in the field of biosecurity, or what is the positive opportunity?
Sure. Yeah. I mean, of course, in biosecurity, it is quite a sensitive field, but the real opportunity is not about replacing the mechanisms that we already have. It's about making them work better in practice. And so that's where tools like AI can come in and make those existing systems catch up to where we are and make those systems work better. So, specifically with the technologies that we looked at in the publication, we found that they can really improve traceability of biological materials. They can improve documentation for laboratory workers, and they improve that ability to be consistent with reporting. So if some states don't have that capacity we talked about previously, they can use some of these tools to help bridge that gap.
That sounds all reassuring. But if we anyhow look a bit at the risks, if we rely so heavily on these purely technical solutions, what do you think?
Sure. And I think, really relying too heavily on especially emerging technology, as it does change so quickly, is relying on that false sense of confidence. So just because a system is suddenly digital and the hot new AI tool, it doesn't mean that the underlying data that's being fed into that system is accurate. So we do have to be careful with that. There's also the issue of uneven adoption. So I mentioned, again, the capacity that different states' parties have to report. If states' parties are unable to adopt technology at the same rate as each other, we're going to have inconsistent results. So that's another issue. And of course, there's also the broader governance question. If a technology is introduced, especially when we're looking at a technology that aids in information to prevent the spread of biological weapons, we have to ensure that there are clear standards, guidelines, guardrails that are understood, agreed, in place. If there's not a guiding framework before that technology is put in place, we're not going to have consistent information systems that actually can talk to each other.
And speaking of talking to each other, if I understand you correctly, you're suggesting that the actors in this field should share the information. And how realistic is that in today's political climate?
I do think that that is quite a challenge. Yeah, definitely. There is always going to be more complication when we try to consider the geopolitical side of things and how that can change the atmosphere. But there is, as I mentioned previously, a shared interest in reducing biological risk. As we saw with COVID-19, we saw that biological threats don't care what country you live in or care about your border disputes or etc. They can affect everyone equally, and eventually those threats need to be addressed by the globe. So I think cooperation is possible in a more competitive environment. They can happen at the same time. So I think bringing these topics into the conversation and ensuring that states parties and stakeholders are talking about these things is really the first necessary step.
And where would you like to see this work for you going forward?
Yes, I think really looking at what our priorities are as far as staying focused on building competence and strengthening our ability to implement when we're talking about biological research. How do we actually do that in practice? How do we make it stronger in practice? And being able to actually make those recommendations in a meaningful way. I think that involves paying attention to things like human oversight, making sure that the human is still involved, ensuring that systems are interoperable, they're able to work together, and ensuring that we're able to have equitable access to tools. With that, that will determine whether those tools are actually useful or not. So I think with our research agenda, especially for SIPRI, with chemical biological weapons especially, we'll be looking at how risk is created in these real world systems, whether it's in conflict environments or supply chains, global supply chains, or in situations where decisions have to be made with incomplete information, which we know happens a lot. So that's really where governance approaches are struggling and where we can bridge those gaps.
Super interesting. We keep watching your work, and we will, of course, make the report available in the show notes. Thank you, really, Miranda. Congratulations again.